Good morning and welcome to day 2 of the Smart Buildings Exchange. My name is Carrie Mead and I'm the Executive Director of the Smart Buildings Center. We're kicking off our second day of the conference momentarily with a keynote panel moderated by Poppy Storm, the founder and Director of Innovation at the 2050 Institute. But before we start, I wanted to run through some housekeeping announcements about virtual participation. First, you will want to use the official SBX WebEx event web app and conference platform to navigate to all the sessions throughout the day. Each session has its own link and they can be found under each session in the agenda. All of today's sessions will be taking place live on Zoom. Our final session tomorrow will not be live streamed, but a recording will be made available to all conference registrants shortly after the conference concludes. Most of the sessions will be in Zoom webinar, which is the setting we are in now. This means that as attendees, you are not visible to each other. The sponsor breakout rooms today will be in a Zoom meeting where you'll have a chance to turn on your cameras and interact. For all your questions, please be sure to use the Q&A function. All of today's sessions will be recorded so that you can watch anything you missed after the event is over. Recordings will be made available online in the coming days. Lastly, I want to give a big shout out to our conference sponsors, the Washington State Department of Commerce, McKinstry, McDonald Miller, Puget Sound Energy, Seattle City Light, ATS Automation, Better Bricks, Long Building Technologies, Belimo, Overcast Innovations, DB Engineering, ACE IoT Solutions, Alps Controls, and BrainBox AI. Without our sponsors' help, we would be unable to bring this 3-day programming to you. So thank you. Without further delay, it is my pleasure to open this conference and turn the mic over to Poppy Storm, the Director of Innovation at the 2050 Institute. Take it away, Poppy.
Great, thank you, Carrie, and good morning, everyone. I'm really excited to be moderating this panel today and meeting with all of you, looking at smart approaches for building electrification and carbon reduction. So we're going to be looking at this in terms of individual buildings and solutions for individual buildings, but also how these approaches can deliver the scale and pace of electrification that's required to meet 2050 emissions limits. So first, I'm going to introduce all of our panelists here today, and then each panelist is going to do a brief presentation just to provide some background on the work they're doing and how it ties into this larger theme. And then we're going to spend the rest of the session on the panel discussion. And I just wanted to remind folks that audience members can ask questions throughout the session by using the Q&A dialog box. So I'm going to start out with Brett Bridgeland. He is a manager with RMI's carbon-free building practice, and he works on the Pathways to Zero initiative. And that initiative focuses on driving the adoption of super efficient and net zero energy buildings. And he is going to be focusing on the challenge of big buildings, his experience in New York, and how especially larger buildings can transition over time. And then we also have Alexi Miller, who is the Acting Director of Building Innovation at NBI. And he helps to lead initiatives including Grid Optimal Buildings Initiative and the Advanced Water Heating Initiative. And he's deeply involved in projects relating to emerging technology, building electrification, and also building grid integration. So that bigger picture of getting to zero across a wide variety of building types. And he's really going to be focusing on solutions that are available, especially with real buildings and difficulties to decarbonize, and also the financial lift that is involved. And then we also have David Nemtzow, who is a senior advisor at the U.S. Department of Energy's Loan Programs Office. So amongst many other responsibilities, he coordinates the LPO's Virtual Power Plant Initiative. And that initiative provides financing to large, innovative interconnected projects built on renewables, demand flexibility, efficiency, storage, EVs, and the whole gamut of distributed energy resources. So he's bringing more of a perspective on the federal government support and commitment to this transition, and then also financial streams from the federal government to states, and then to projects and how to access them and when. And then finally, we have McGee Young, who is the founder of WattCarbon, which includes a marketplace for eliminating fossil fuels by funding decarbonization projects in buildings across the country. And that WattCarbon marketplace includes options for electrification, but also demand response and renewables. So he's looking more at the carbon content of this transition and the carbon content of the serving utilities, and how do we know and how do we manage for reducing carbon, and what is the role of rate structures. So that's looking more bigger picture at scale. How do we transition this in other ways than just traditional incentives and funding mechanisms? So with that, I'm going to switch over to the presentations, and I'm going to start with some slides just to provide some context for the overall discussion. So just give me a second here and I will start sharing my screen. So I'm looking at, in my presentation for the context, scaling electrification on a tight timeline, because we're not just looking at smart approaches for individual buildings. We're talking about how can we approach this with more innovation in terms of large-scale mobilization and implementation of electrification on a tight timeline. And I'm going to use an example of Washington State, where I have been doing working on a number of related projects in the last few years. So just to give you an overview, for Washington State, we've been charting a path to building decarbonization. We have a state energy strategy from 2021 that I helped work on, the building sector strategy in particular. And that is defining this overall state direction and identified electrification in buildings as the most strategic and lowest cost approach to meeting our 2050 emissions limits. And then there was a follow-on study which was funded by the Clean Energy Transition Institute called Operation 2030, and that's scaling building decarbonization in Washington State. So going from these higher level goals of a state energy strategy to looking at how do we actually really do that? What does scaling mean? How do we get some better definition between now and 300 years from now or 50 years from now, as they were discussing in the plenary yesterday? We want to really shrink that time frame, so we need to be thinking about what we really have to do in not even just the near term, but kind of the immediate term. And so that's leading into something called Scale 2030, which we're launching here in Washington State, which is looking at what is the systemic change that's really required for large-scale mobilization, and how can we be thinking about this from an ecosystem perspective, and how we shift the entire ecosystem to help deliver these decarbonization outcomes that we're after. And then finally, there is a related project the CETI is working on that just released, which is Net Zero Northwest. So looking at economy-wide decarbonization analysis along the lines of what we've seen at the state level in this country and at the national level, and then also at the international level. And we're seeing a lot of similarity across those. So really what I just want to focus in on is what is the scope of our challenge here? So we're looking at total building decarbonization by 2050. And I feel like I can pretty safely say that most of this analysis from Washington State really likely applies to most other states in this country and pretty much anywhere in the world, and even cities that we've looked at within this country. So it's not just incremental decarbonization. It's not just the decarbonization that you get from incremental amounts of efficiency. That's the 20th century. That's over. We're in a totally different paradigm now where we need to decarbonize the entire building stock by 2050. And so what you can see in these graphs, that we have historical emissions for Washington State for buildings on the left with the blue line since 1990 to about 2020, so a 30-year time frame. We increased our emissions in buildings by almost 50%. And now, in what I call our new 30 years, where we have an opportunity to do things in a bigger and bolder and maybe totally different way, we need to reduce emissions by nearly 100%. And so we need really a steep ramp up in the next 30 years, and then we need to gradually replace all of the emitting equipment by 2050. So it's a big task, but we can do it if we really recognize that that is actually what the job is, and it's not incremental efficiency or half measures. So in Washington State, we're seeing that going electrification versus the alternative, which is business as usual, or in this case of this $34 billion in savings, this is compared to going a decarbonized pipeline gas path. So if we keep all of the lower efficiency combustion equipment in buildings, but we decarbonize the gas, that will cost $34 billion more by 2050 in cumulative terms than going electrification in buildings for space and water heating and other appliances. So $34 billion is a really significant amount, especially if it's just for one state. So this is has the potential for really broad-reaching benefits. So we really need to start thinking about it in those terms and not just be thinking about these really high first costs. We need to lower those, but we need to think about how do we distribute those costs, because we are going to be experiencing these highly distributed benefits, since most of this $34 billion is realized by individual consumers, individual housing units, and businesses in terms of reduced energy costs. So the key to this for Washington, and I'm seeing this across a lot of other studies, is that to get that building sector to be completely transitioned by 2050, the actual buildings, we need to shift the market by 2030. So we have just over 5 years to make it so that these types of strategies are the norm across the entire building sector. It can't be a niche thing anymore. And I really don't see individual incentives getting us all the way to this shift by 2030, where every new and replacement piece of equipment is zero emissions. And in this case, it was modeled as electric equipment, high efficiency electric equipment. So we need a very big market push, and we need a whole ecosystem that delivers this. So just quickly, I'm not going to go into the details here, but what this culminates into is that we need really clear phases. And I think we can see these phases overlapping with a lot of the other things and solutions that the other panelists are going to be describing, because everything that they're talking about is really tying into this larger transition. It's not just about how do you get it right for an individual building. So we're really looking at getting this policy and planning platform stood up by 2025, and then a very rapid ramp up to 100% sales share of electric zero emissions equipment by 2030. And then we gradually replace all that equipment between 2030 and 2050. So the question, though, is what is keeping the building sector ecosystem from delivering decarbonization at scale and at this scale? And we have a myriad of issues. This is some of the higher level ones. There are many more, but we have overall a lot of complexity at the ecosystem level and system friction and how all these different approaches are interacting. We have very high incremental first costs. I would say potentially prohibitive, even with the incentives that are being offered. We're seeing a really high incremental first cost that is a non-starter for a lot of decision makers. There's also a lack of alignment and interconnectivity across policies and programs and essential market activities. And there has traditionally been a focus on incremental change and approaches with high administrative burden. And we also have high levels of economic insecurity. We have in Washington, for example, 40 to 50% of the households are low to moderate income households. And that has implications not just for the residential sector transition, but for the overall transition. And so we really need to be thinking about how to do this equitably. So just a quick recap on how this is culminating into these Scale 2030 initiatives. I want to just go over these before we switch over to the other panelists' presentations, because they really tie into some of these bigger ideas that are going to be discussed today and that I think are very important for this transition if we're in it to win it by 2050 and we know what it takes to get to 2050 in terms of what we need to hit by 2030 and the scale that we need to hit by 2030. So we're looking at mapping systemic barriers, identifying what the key requirements would be of a truly high-performing building decarbonization ecosystem. Something where this decarbonization is a natural outcome of the high performance of the ecosystem instead of a lot of the system friction that we have right now. And we're also developing a building decarbonization roadmap to support the ecosystem. What would those policy changes be that would actually be connected into the type of systemic change we need at the ecosystem level? And then there's a blueprint for deep cost reductions, really placing cost, more heavily weighting cost as a systemic barrier, as truly the overarching barrier, the barrier behind almost all the other barriers. It's really about cost, and we really need to hit that head on. And that will be a topic for today's panel. And then for us here, we do regional power planning because of our Bonneville Power Administration dam system. And we really need to align that power planning with our decarbonization policy, particularly for our largest states like Oregon and Washington. And I think that that is a similar case in other parts of the country and the world, where we're trying to transition from this efficiency mindset and all of the methodologies around that and kind of break that apart, but build on it to move into this decarbonization paradigm. And then there's also the potential for rate reform to be a real driver for equitable decarbonization. So I'm going to stop there and stop sharing my screen, and I'm going to hand things over to Brett.
Great, thank you, Poppy. Okay, and I should be sharing my screen. Let me know if there's any problems. But so I'm Brett Bridgeland, principal with ARMA in our carbon-free buildings practice. I'm going to take about 10 minutes here and run through some of our recent work and insights that I think are additive to the conversation, and hopefully start to address some of the questions and concerns that Poppy laid out in the opening here. So, and this is under the heading of this term called strategic decarbonization, which I'll explain what we mean by that. But before we dive into that, one of the things that we've been tracking over the last, I don't know, 5, 6, 7 years is the emissions reduction potential of electrification of heating in particular. So this is the latest update of that latest, greatest data, and looking at grid emissions, looking at efficiency of heat pumps, which are no longer just for mild climates. We've got cold climate heat pumps that work well, what we see today is that the verdict is in. Heat pumps reduce emissions everywhere across the United States on day one, in some places by a lot, in some places by perhaps more modest amounts. But the verdict is in. Heat pumps reduce emissions, and the other key part of this is that it's not just about day one. It's about how long that equipment is going to last, because that equipment's going to be in these homes and buildings for 20 plus years. And so if you look across the lifetime of emissions, even just taking a 15-year lifetime, heat pumps are going to save far more emissions compared to gas. So runaway favorite. This it was looking at residential furnace replacements in particular, but assuming the same sort of efficiencies, we should see that in other larger systems as well. The other part, as Poppy alluded to, is cost effectiveness, of course, and this is something we've been tracking, looking at new construction as an indicator. And here again, latest data is in, and what we see is cost effectiveness across all climate zones for going all electric and new construction from day one. And actually, that's on an operational cost and a first cost basis, both. So heat pumps, cost effective in residential new construction. In retrofit applications, it quickly becomes more nuanced and bespoke, but you can see similar verdicts when replacing expensive delivered fuels. You can see similar verdicts in situations like when you're replacing all the systems in a home. And in places like the Northwest, people are going to be adding cooling for the first time as climate changes. That's a great opportunity to think holistically and receive benefits from looking at heat pumps as opposed to split sort of dual fuel retrofit applications. So that was a quick snapshot on our sort of latest on residential and sort of top-down looks at the benefits of heat pumps. I'm going to spend the rest of my time here talking about commercial buildings, which is where I spend a lot of my time personally. There's been a lot of dialogue about residential buildings, and I think over the last year or two, commercial buildings have really come into the discussion because there are a lot more system types, and where the typology needs to enter the lexicon of planners and real estate portfolios and implementers. So starting small, so small commercial. This is stats from the CBEX survey, looking at the equipment stock that's out there in U.S. buildings. And that top line, packaged heating units, is by far the largest share. This is sort of the ubiquitous workhorse of commercial heating and cooling is the packaged rooftop unit, which you see everywhere from big box stores to retail and warehouse and schools and even ventilation systems and all building types. So ubiquitous system types. There are products out there off the shelf that can be swapped in for gas-fired rooftop units today. And when we ran the analysis on these, so the economics of small commercial electrification, what we found is that across 4 illustrative climate zones and electricity markets, gas-fired or heat pump RTUs can be swapped in at end of equipment life cost effectively. And one thing I want to highlight here is that depending on where you are in the circumstances, it may not be as simple as just a 1-for-1 swap out, walk away, you're done. It may still require an integrated sort of approach to make it economical. So it may include adding efficiency measures in ventilation or fan efficiency to help the economics, or integrating demand management to manage peak charges, or integrating with PV. So even in the sort of most simple commoditized system, integrated approaches may be beneficial to make to improve the economics. On small commercial, quickly, I'd be remiss if I didn't mention that there are super efficient system options out there as well in circumstances where you could look at a more comprehensive retrofit. So variable refrigerant flow, or there's a version of that called hybrid, which takes the refrigerant out of the lines in the building and uses water to move heat around. So in instances where a more holistic retrofit is possible, there are even more efficient systems. Okay, so moving up a scale to large commercial buildings, the dialogue often goes quickly to this: like, what's the equipment? Where's the heat coming from? The heat generation, and there are different components: larger VRF systems, air to water heat pumps, ground source heat pumps, heat recovery chillers. These things are good; they're definitely part of the solution. But there are challenges / opportunities as we move into these larger building types. And so many building types run on high temperature hot water or steam, and the distribution systems within the buildings will also require work. Making those transitions can be disruptive to occupants and tenants. In larger buildings, you have to think about where your heat sources are, how much roof space you have for heat pumps, how much mechanical room space, and of course, the big capital investment. So the answer to this that we're starting to see from some leading practitioners, real estate partners, and programs is this approach we're calling strategic decarbonization, which, rather than jump to that last bar on the right, the full electrification, it thinks about these steps to get there, which enable it and make it possible and feasible and beneficial. And those steps include reducing loads. We, as an industry, have been talking about efficiency first for 40 plus years. So that's part of it. There's also an element of, like I said, reconfiguring systems in buildings, sometimes moving to water-based hydronic systems, which is an opportunity for both efficiency as well as heat recovery, which is the next box. And so recovering heat, I'll come back to that in a minute, from all the sources that are possible. And then talking about the heat generation side. And here again, there's a lot that can be done with immediately with relatively modest sort of investments in buildings, so that partial electrification can realize 80% electrification of loads with pretty good economics, using different heat generation sources. And then that full electrification, the design condition, which happens a few hours of the year, can be solved in deliberately, potentially in different ways, potentially over time. So this sort of enabling approach is we're calling strategic decarbonization. This is in my work. This is emerging work that we're doing in New York, where NYSERDA, the state's energy office, is running programs to help large and tall buildings specifically figure out one of the more challenging aspects of building decarbonization, how to decarbonize these building types across both commercial buildings and multifamily buildings. And so these are 4 winners of the first cohort of projects, and these projects are in process of implementing their designs. The 2 on the left, which are both affordable multifamily projects, include overcladding to reduce loads, and then shifting towards heat pump heating, including the one on the far left is an integrated system that does heating, cooling, and domestic hot water. I'll highlight the one all the way on the right, Hudson Square, really interesting project where they're going to turn over tenants over the course of, I forget, a decade, and it's in sort of 3 phases. What they're doing is running a new hydronic spine through the building, and then as tenants roll, they're going to plug into that system, which is fed by heat pumps and heat recovery on the roof. And so it's a phased approach that matches the asset sort of life cycle and tenant management cycle. So really exciting, replicable approach. And before we go thinking that this is all just happening in New York with NYSERDA funding, highlight They're in King County, really exciting thing happening that we talk about in New York. We'd love to see this replicated elsewhere. Sewer heat recovery. So there's an opportunity in urban environments to recover heat from municipal sewer lines or even within multifamily buildings themselves. This is a really interesting leading project nationally and a great solution for urban heat sources. Another example, so those are individual buildings, but scaling up, we had an engagement with Canada's National Capital region. So looking at their federal buildings, about a 60 million square foot portfolio. One thing I want to highlight here is that in strategic decarbonization, those interactive effects matter. So heat pumps, just a simple swap out, had a prohibitive payback, but integrating efficiency and then even non-HVAC measures brought that to a reasonable payback. And the other part is tying this to triggers rather than sort of investments apropos of nothing, whether it's equipment end of life or repositioning or capitalization. And in that Canadian example, what we saw is when we do things on triggers that make sense in the asset's life cycle, the incremental cost was only 5% higher than business as usual to get to complete decarbonization on over 30 years, which was their time frame. So positive look there. When we tie to triggers, take a portfolio over time approach. And the question, which I think we'll get into in the discussion, is how do we scale this? Because globally, 70% of buildings are still going to be here in 2050, probably even higher. This is global, so even higher in the US. So with that, I will go back to Poppy here and our next presenter.
Great, thank you so much, Brett. Now we're going to go to Alexi.
All right, great. Thanks, Poppy, and thanks, Brett and others. It's been really excellent. So I'm going to talk a little bit. I'll try to keep it pretty brief. I think we all know why we're talking about buildings, right? It's something globally around 40% of all our greenhouse gas emissions coming from both direct, that's burning gas on site, and indirect, that's associated with the upstream energy coming into buildings. And of course, it's the smart buildings topic that we're focusing on today. So I'd be remiss in pointing out that the grid exists to serve buildings. Our electricity system here in the US, about 3/4 of all the power we generate goes into a building of one type or another that is more in peak conditions. So we've got this fantastically complex, amazing machine that is our power grid, and it's serving these buildings. That's mostly what it's here to do, where of course we spend 90+% of our time. And so that's why they're so central to decarbonization solutions. Why such a focus on decarbonizing buildings? Well, I think it's maybe a misattributed quote, but Willie Sutton, the bank robber in the 20s-ish, was quoted as saying, I rob banks because that's where the money is. Well, we decarbonize buildings because that's where the carbon is. So apologies to Willie if that's misattributed, but that's really the point, right? Find where the carbon is and go get it. We know we need to do it. We know where it sits. And so then the question is how? Where is this greenhouse gas coming from in buildings? Broadly speaking, we're talking about space heating, water heating, mostly those two. And then, there's some other stuff, cooking, laundry, direct use in other ways, process loads, right? But the big two are space heating and water heating. And so the answer is more or less spelled heat pumps. There's other stuff too. But when we're talking about decarbonization in buildings for those two big loads, space heating and water heating, we're mostly talking about heat pumps, which is, I was gratified to see Brett really focusing on those because that's the big deal. How ready are these key solutions? Basically, we know how to do this. the story of decarbonization being largely the story of heat pumps. Heat pumps for nearly every application are ready to go. They're available off the shelf. There are some cases where, you know, they've still got some ways to go and there's some improvement to be made, but for the most part, the products are there. And now we're talking about the other roadblocks. We need more demand from the building industry side. We're going to make sure that supply chain is robust, that manufacturers have the confidence they need to really scale up production to meet a higher demand. And of course, we've got some of those alignment issues that we've heard about already and incremental cost gaps. But we're talking about a big scale, right? We're talking about moving from maybe a 5% adoption rate to getting toward 100% adoption rate in a short time frame. So it really is all about scale. And I want to give a couple of specific examples. There are some silver bullet product types. For example, the heat pump water heater. One of my roles at MBI is to oversee a couple of our initiatives, one of which is the Advanced Water Heating Initiative, AWHI. It's all about bringing heat pump water heaters to scale. And the reason we're focusing on this particular technology is it really is one of these silver bullets. It combines three key value streams. They're very high efficiency. Heat pump water heaters are 2, 3, sometimes 4+%. Times 200, 300, 400%, if you like, more efficient than the baseline gas burning or electric resistance water heaters they replace. Of course, they're all electric. And so the energy coming into the heat pump water heater can be cleaned up at the grid scale, whereas it's very difficult to clean up the gas network in the same way. The solutions really just are not scaling like they are in electricity. And then, of course, they're smart. Heat pump water heaters are by nature thermal energy batteries. They are energy storage devices as a big tank of hot water. And generally speaking, heat pump water heaters come smart by default. The chips are there to be able to participate in smart grid programs, and the incremental cost to make sure that they've got that communications capability, which is a future-proofing element for buildings, right? Make sure that buildings are not left behind as rate structures evolve, as utility programs evolve. That incremental cost is really low. And in some cases, it's just required anyway, like Washington State as one of our examples. So those three key value streams are why they come together and they make this really a silver bullet technology. Of course, they're there now. You can go to the hardware store. Actually, going back up one, that heat pump water heater in that picture is one I put into my mother-in-law's basement. She calls it her spaceship. She's very happy with it. Got it. It was a very easy process with incredibly generous rebates from my local utility. But there are more products coming. For example, plug-in retrofit ready 120 volt heat pump water heaters, which are a really important retrofit technology so that you don't have to upgrade electrical capacity, put in a new circuit, et cetera, to serve a 240 volt line. If you're previously running off of just gas, you could just plug the thing in. There's some interesting product classes, 120 gallon commercial units that can sometimes be ganged up. We've got these skid-mounted central systems like this one up in Bayview Tower in Seattle. And of course, there's new stuff coming and with really strong support from the federal government, seeing new work on form factors, which is to say shapes, right, to fit into different configurations, updated refrigerants that have lower global warming potential, better connectivity on these different systems, all kinds of cool stuff, right? So it's a silver bullet technology as it stands now. It's improving in terms of efficiency, performance, and all the bells and whistles. And that's an example of where we need to go. And the key thing is it's got these multiple value streams that are coming together: efficiency, electrification, smart, and then you see multiple value streams on the building scale. So I want to give, that's an example of a technology. I want to give a little example of a project that I think is really relevant in terms of tying together these multiple value streams, because that's how I think we can succeed in really scaling this, is making sure that we're not only focusing on the payback in terms of energy costs from a decarbonization project, because if done right, they should be much more than just an energy savings project. So this is an affordable housing development in Vermont. New construction, affordable multifamily built in 2016, several years back. It's 14 homes, around 1,000 square feet apiece. They're all electric and include very high efficiency equipment, heat pumps, of course, for space and water heat. And it's, this is Vermont, so it's cold. It's a case in point that you can do this in basically every climate we have. And then they also include energy storage, that is to say batteries, and rooftop solar. And the really interesting thing about this project is the layering of the efficiency, the equipment, the DERs, the distributed energy resources, right? And the smart component of them enables us to get this multi-value stream. It's what I like to say is a win-win-win proposition. We've got occupants, that's a win for them. They're paying $5 a month average on their energy bill in Vermont. So remarkable cost savings for the occupants, which is really important. That lowers their energy burden. That's a really significant equity benefit for people in affordable multifamily buildings, right? $5 a month, I wish my energy bill were $5 a month. That would be great. They're also getting 148 hours on average of resilience from grid outages. That the solar plus storage and some of the smart controls is giving them protection for when the grid goes down, they can still be up. 148 hours a year is pretty significant. So they're getting these two major benefits, economic and resilience benefits, not to mention a much more comfortable house than you might expect. Or than maybe what is the baseline, right? At the utility scale, right, that's the occupant side of the meter. On the utility side of the meter, they're looking at hundreds of dollars a month savings in transmission charge management. And they're also getting their coincident peak reduction, the coincident grid peak demand is cut in half. That is to say, the demand of the building during times of peak grid demand, when the load on the grid is high, is half what it would have been. So that's a huge impact on the grid, right? You can do, it's 2 for 1. You can do 2 of these buildings at the same grid impact of 1 of these buildings. And then of course, the society, we're talking about 30-some metric tons of CO2 equivalent per year being saved by this layered combination of efficiency, electrification, distributed energy resources, and smart controls. And NREL's analysis showed that part of the key to this, to unlocking this win-win-win proposition, was tuning the sizing of the equipment, the selection of the equipment, and the dispatch strategy of things like that battery and other components, like HVAC controls, for instance, to simultaneously minimize the energy cost, the life cycle cost, and the climate impact. And so you can say, where is the best fit for this? And NREL actually created an open source tool to help develop that, right? Figure out what are our priorities, how do we do this multi-priority optimization? So that's that kind of win-win-win solution that I think is really going to help us scale this up. We really do need to scale this up. We know what to do, broadly speaking, in buildings. It's, as I said, spelled heat pumps. It's ready, it's available today. As we've seen, the economics are already scalable, but getting better fast, thanks to the IRA, the infrastructure bill, other federal legislation, as well as state policy. We really do need a significant focus on bringing down those upfront costs. Like it or not, most people in our current economic construct don't really think in life cycle costs. We're talking about first costs in a lot of cases. And so we really do need to bring those upfront costs down in terms of the equipment and of course the labor. But I think it's got a lot to do with finding these multi-value stream opportunities, these win-win-wins, so that we can equitably deliver improved energy efficiency, we can cut those operating costs, we can really deliver on improved resiliency. A lot of times that may be the driver that gets people to actually do the project. It may be a decarbonization project, but if they think of it as a resiliency project, onward and upward. And of course, we want better building outcomes, better performance, better comfort. And we can still get all those sweet environmental benefits. So thank you.
Great, thank you so much, Alexi. Well, with Alexi's presentation and Brett's, we have a good foundation for what's actually out there in terms of technologies and different approaches, but also this need to scale. And so now we're going to move to talk about more solutions on the finance side of things. And I'm going to go first to David to talk about what he's doing at the LPO.
Great, thanks, Poppy. David Nemtzow here from U.S. Department of Energy Loan Programs Office. First, thanks to Smart Building Center and for organizing SBX and inviting DOE to participate. And it's great to be on this panel with colleagues. And, there's a bit of what I want to say, there's a bit of, as we say in Washington, everything has been said, but not everybody has said it. So there'll be a little of that. Alexi, next time I'm going before you, Alexi, so I can talk about the role of buildings in the economy. So I'll add one thing you didn't say, that of that 3/4 of US power that buildings use, the highest energy consuming sector, as I think everybody in this virtual room knows, that means that buildings are spending over US buildings are spending over $400 billion per annum for their energy needs. And pick your number, I'd say well over 1/3 of that is wasted. And that's the magnitude of the challenge and the opportunity. So that's what we're going to talk about. I am going to switch a bit and not talk about specific technologies and opportunities, talk more broadly about financing. And I know what you're all thinking. It's the 1-year anniversary of the Inflation Reduction Act, followed the bipartisan infrastructure law. So U.S. government and DOE have all this money to give out, and I'm going to tell you where to find all that money. So I'm going to disappoint you. We have so many different opportunities and so much money of different kinds that I can't even tell you. I don't have a cheat sheet of my own to tell you all the programs. I get contacted all the time. You're welcome to contact me. I'll give you my email address. That's in my slides, first.last at hq.doe.gov. And in fact, that works for all of us. If you want to reach out to anybody else, we have so many different programs now, and they're new enough that there isn't a single resource yet for all the opportunities going on. So that's on us, but I hope you take that as we do as a sign of all the activities that are going. And that's just DOE. That doesn't count EPA, and of course the tax credits live at Treasury, et cetera, et cetera. So the opportunities are enormous. And as you may well know, just recently DOE, the administration issued new guidelines for the states on rebates for energy efficient and products, including electrification, including heat pumps. So those are not yet on the street. They will vary at the state level, of course. But we DOE issued guidance to the states to go forward, and then they will apply their own discretion. I want to focus on what I do for a living. So I'm in the loan programs office. I'm gonna put up some slides. And at the DOE Loan Programs Office, we do what the name implies. We lend money. And we do it in a couple of forms. And I won't go deeply into the finance part of it today. I'm happy to follow up afterwards. But we provide loans or loan guarantees for qualifying clean energy projects. And if you look down here in this slide, I think what we're all interested in this virtual room is innovative clean energy. These are just our different programs. But if you want to build an EV battery factory, or you work with Native Americans, et cetera, we have other programs. I want to focus on that. And within our innovative clean energy program, which is for renewables and efficiency, storage, I'm going to focus on a subset that I personally work on called virtual power plants. And I hope you know what a virtual power plant is. It's a term that's come on strongly lately. If you don't worry, I have a definition. In fact, I have a list of 41 different definitions of virtual power plants, only 2 of which I've written myself, one of which is from Brett's colleagues at RMI, but it's a new enough term that our definitions vary. But I'll get into my definition of it in a moment. But what I want to talk about is scale. So virtual power plants are, I don't know, first, I'm sorry, I need to have a word from our sponsor, people who pay my salary, and tell you about the Loan Programs Office. So we lend money. So what? A lot of people lend money, such as Goldman Sachs, such as Bank of America. So in some ways, we're similar. If you can get commercial money for a project, go for it. You might do better than us. Where we do better and where we have a lot of appeal is that we can be very patient. We can do 25-year loan terms, which is not very common.
Great.
My phone decided to hang up. Go figure. Thank you, Verizon, but wasn't my fault. But again, it is of course, our steady reminder that smartness has its flaws. As someone once said at a building performance association meeting, yeah, I like those smart thermostats, but I'll tell you this: when I install insulation in somebody's home, I never get an error 46 message. So there's some truth to that too, right? So anyhow, smartness is essential to this. So look, we provide finance. It's cheaper than commercial finance for most applicants. It's longer term, and we form a partnership, and we have a lot of money. The IRA gave us, in total, not just for virtual power plants, over $350 billion in lending authority. So I will say at the end of this, come talk to me. So I think you all know about smart buildings, of course, and I know there is a separate session on grid interactive efficient buildings. This is just to remind you how many different forms of smartness there are in today's residential and commercial buildings. So first, to scale it up, we do something. This is a photo of a schema of what I'll call a connected community, where we go beyond individual buildings and look at it at a community level. Obviously, this is one example. It's an affluent single-family community in which our goal is to do, as it says in yellow, do where the sum, what the community as a whole can do more than the sum of the parts. And by scaling up, we can have a better chance of making sure that there aren't, if technology isn't appealing to one end user, it'll be appealing to enough other end users that it can be used as a whole. So that's the kind of scale we want. So it's not just bigger numbers, but it's more reliable. And that's going to invite my definition of what is a virtual power plant. So I'll let you read that for yourself. But the key point I want to make here is that if you want to ask what's the difference between a virtual power plant and just a lot of distributed energy resources, and whether that's solar or storage or energy efficiency or demand response, the difference is that by being large enough, it can be utility scale, tens and hundreds of megawatts instead of tens of kilowatts. And more importantly, it can be connected and smart enough and control enough to be considered utility grade. It's not a power plant, but it can act like a power plant. And I'll just click through here and let you read it for yourself. And so these are the, on the left, these are the aspects. They don't have to be physically co-located. Again, that helps us scale. They can respond to all sorts of signals. There are a lot of different benefits depending on price signals and regulatory and market signals. There may be aggregators involved, but there's also, it can be done by third-party aggregators, by utilities, by OEMs who want to aggregate up, et cetera. And there are a lot of advantages. I'm going to focus on decarbonization and electrification today, but there also can be very essential for resilience and reliability. We're very open-minded at DOE as to what technologies qualify. I have a graphic version of this in a minute. We're very open-minded. We don't have to, we want to be inclusive as to the different distributed energy resources that qualify as a virtual power plant. And so again, they're utility scale and utility grade. My office is driven by applications. And we'll have a new report coming out, by the way. I want to give you a heads up, and I'll, when it's available, I'll ask the Smart Building Center and the Exchange to share it with participants in mid-September, a commercialization report for virtual power plants. But when we look at virtual power plants, what we want to do is include all these resources. In my office at LPO, we provide financing. So if any of you were to come in and say, hey, David, I want to do a virtual power plant that's a mix of, I don't know, pick your numbers, 50,000 homes with PV and storage and demand response software, and I need to borrow $500 million, then we can talk. You want to borrow $2 billion, we can talk. Our most recent loan guarantee was to Ford for $9 billion. And so we can well get into the billions. Most virtual power plants are smaller, in the hundreds of millions and billions. So just want to give you a sense of excitement. Of course, if it was all that simple, I wouldn't be here, I wouldn't need to have this conference. Life's more complicated. So not every utility has the right incentives for DERs, of course, let alone for virtual power plants at scale. There's still a perception after all these years, Stan Price, that among utilities and others, that DERs, including virtual power plants, aren't reliable enough for their needs, which I find to be a joke, frankly. After we saw what happened, we see that even traditional resources, power plants and others, they're not perfectly reliable either. Yet nobody seems to be as bothered by those. Reliability comes in many forms. We do need to standardize data access. We need to have the regulatory mechanisms at FERC, but mostly at the PUC level. We don't want to leave out low and moderate income households or other disadvantaged Americans from the clean energy revolution or the VPP part of it. And we want to make sure that commercial lenders understand all of the above so that they can make reasonable ratings. That's a role that LPO in particular plays in. Here's the picture version. Again, they come in many shapes and sizes. And even though it's a conference on buildings, you can see there, including a bidirectional EV, the F-150 Lightning. And it's the node, of course, is the home. Swell and Hawaiian Electric have a virtual power plant, actually in Maui, going on. And virtual power plants can include any or all the above. And of course, we already talked about about heat pumps, and we can use, of course, smartness to be aftermarket with, with radio controlled devices, or of course, it's better if they're built in from the get-go. That's where to find me. And again, we're interested in working with you if you have projects. Thanks very much. Back to you, Poppy.
Thank you, David. And now we're going to hand things over to McGee Young with WattCarbon.
Thank you, Poppy. All right, I've got the anchor leg of the relay race here, and hopefully everybody's got their second cup of coffee and are ready for a great discussion after my presentation. Thanks to all the rest of you for teeing me up to talk about kind of the big picture of, I've heard a lot of it's possible right now, but not a lot of how are we actually going to do this? And so hopefully my presentation can kind of point us in the direction of actually deploying all these great technologies. I'm McGee Young, the founder and CEO of WattCarbon. I'm going to talk about decarbonizing buildings as a form of climate action. That 40% number, we're going to see quite a bit. We saw it earlier. I'll bring it back in a couple of slides. This 40% number, 40% by 2030. This is the reduction in GHG emissions that are going to be required to prevent runaway global warming in the next decade. So we have this massive task ahead of us. We've got a lot of ideas for how to decarbonize different sectors of our economy. What makes buildings different is that we're ready to go right now. And so really for buildings, the question is, can we deploy fast enough to achieve the goals we need to achieve to prevent the worst effects of climate change? In terms of climate action, we see a lot of work that gets done these days, trying to fix nature. And my perspective on this, and I think I share this with probably most of you in the webinar here and at this conference, is that it's not so much that we need to fix nature, we need to fix ourselves. We need to fix the way in which we interact with nature, and we need to fix the way in which we power our economy and live our lives. So this means getting us into real pathways for energy decarbonization, eliminating the use of fossil fuels in our day-to-day existence. We know that we can't stop driving. EVs are going to take a little bit a time to really reach saturation, but we can do this with buildings now. So this is the other 40% number. The emissions, come from buildings. Okay, what's the problem? We need speed and we need scale. at the current rate that we go, we're at about a 300-year timeline to get to building decarbonization in the United States. 300 years ago, George Washington wasn't even born. So if we're not on if we can't get off the 300-year timeline, there's kind of no point in doing this. And we need money. It's going to cost somewhere between $10 and $100 trillion to decarbonize buildings in North America alone. We're not going to do this on the back of utility ratepayer programs. We're not going to do this with the status quo. So we need to get creative around how to fund and finance to solve that upfront cost problem that other folks have mentioned. We think that we need to create an ROI for climate. We need to value the decarbonization potential for buildings, and then start directing funding towards projects that are ready to deploy. We can get out there and do this today. Right now, we replace 20,000 gas furnaces per day in the United States with more gas furnaces. So just on burnout alone, we ought to be doing 10x, 100x of our current heat pump capacity. We need scale. We need the great companies that are out there doing this good work to decarbonize to compete directly with the fossil fuel status quo, to make it so that it's not, I've seen some of the comments so far wondering, gosh, it seems like, fossil fuels are going to be cheaper. So how do we make electrification not just what's good for the climate, what's also good for the bottom line? And some of the work that Brett and Alexi have showcases that this is actually true for many buildings already. But the last thing is that we need to actually prove that what we're doing is making an impact. Right now, climate action is kind of the largest faith-based initiative on the planet. We're mostly doing this stuff and just kind of hoping that it's going to work. But we've got to do a lot better providing transparent measurement and verification of the decarbonization that's happening in these buildings, so that people trust that when they spend money on this, it's going to what they think is going to happen. So for us at WattCarbon, we're thinking about climate impact through the lens of buildings and building a marketplace for the voluntary procurement of the carbon emission reductions from building decarbonization projects. And so what that allows any organization to do, any individual, any nonprofit, any charity, any business with a net zero goal, any government institution that wants to achieve carbon reduction goals can simply procure it, can simply say, I'd like to buy the carbon emission reductions from your decarbonization project and help you fund that work, help you drive the speed and scale that we need to drive into our market. We do that through this kind of creative, innovative marketplace design that involves kind of three really important pieces. Number one is an advanced market commitment. So we're saying ahead of time to the companies that are doing this decarbonization work, whatever carbon emission reductions you're able to achieve, we'll pay you for those. That allows them to wrap that commitment into their offer to their customers, into lower cost financing, into a lower upfront cost for the project itself, into more advertising that allows them to compete directly with the incumbents. It also involves pay for performance. So we don't want to pay for the non-achievement of these emission reductions. So measuring carefully every watt hour, every gram of carbon that gets reduced, and only paying for what actually materializes. And third, and I think most importantly, a carbon price signal. So right now, most of us think about this in terms of the ROI for, our energy bills, or maybe, from a VPP standpoint, can we arbitrage the grid somehow, or can we get some other energy price signal sent to justify this work? We need to send a price signal around carbon. So distributed energy resources are everybody knows this is a lot to try to negotiate individual offtake agreements around. So we've reframed this to think not about buying the carbon reductions from any one given project, but to aggregate projects across similar types of approaches. So electrification, renewable energy, demand response, so that we can bundle together large numbers of these projects and reduce the risk of any one project for somebody who's coming in and financing these portfolios. This again creates the efficiency we need to achieve the speed and scale required to decarbonize buildings. A couple of other really important parts of this: equity. We have to be thoughtful about both the impacts of our carbon-based economy today on local communities, as well as making sure that we don't impose burdens on communities differently. We can't just put heat pumps in rich neighborhoods, but we also can't not put solar panels on poor neighborhoods. And how do we make sure that it's distributed across the United States so that where the utility isn't very motivated to help provide incentives, we can still make sure that they can participate in the energy transition. And then, of course, measurement and verification. We've got smart meters across most of the US. A lot of the work that's going into buildings includes the ability to monitor and measure equipment impacts. There's no reason that we shouldn't be measuring this stuff with incredible precision and accuracy. So that we can be confident that the money that we're spending is actually going to achieve the results that we desire. And finally, additionality. So this is the idea that there's a lot of free ridership maybe happening with traditional rebate programs. It's all of us who are at this conference today who participate in utility rebate programs. We're already going to do this stuff anyway, but we kind of like, the extra money that comes along with taking advantage of a rebate. And I suspect that most of us at one point or another have taken advantage of some of those utility rebates. But what we really need is scale. We need to actually make the rebate invisible to the end customer. So what they know is that they're getting a good deal on a heat pump and their contractor says really good things about it. And so we can pay for the carbon reduction value indirectly to that customer, which creates the full additionality that we're looking for as we spend money towards these types of projects, knowing that every dollar that's going out is creating carbon reduction impacts at the end of the day. So this hopefully sets the scenes for quite a robust discussion, getting us, Poppy has prepared a bunch of really great questions for us. I'm sure there's a number coming in from the audience. Really looking forward to continuing the conversation with the rest of the panelists. Thanks for having me on today.
Great, thank you, McGee, and thank you all four of you today. I wanted to just jump in with some questions around the gap potentially between some of these solutions at the individual building level and this more overarching solution that McGee has just been discussing. So maybe we can start with an assumption that we have, or it seems to be emerging from some of the earlier presentations around having ready solutions. And the ready solutions that were described seem to be the type of things that can fit within this paradigm that McGee is talking about and maybe solve some of the barriers that you all were talking about in your early presentation. So my question is mainly for Alexi and Brett is, do we really feel like we're at a point where we have the solutions, even though it might be a little tricky for the larger buildings? Are we ready to actually hit this level of speed and scale? And in addition, what type of time frame do you think that we're really looking at? Do we think that we can do it by 2030? And when I say 2030 market transition, I don't mean that everything needs to be electrified immediately. It's that by 2030, when a building is replacing their equipment or a new piece of equipment is going in, it's zero emissions. It's likely all electric. So are we in a position with the solutions to actually deliver on that type of time frame between like 2030 and 2035?
Maybe I can jump in first, if that's all right, Brett. So one of the states with the very most aggressive climate action goals is California. The California Energy Commission held a workshop with some major heat pump manufacturers. They've got a goal to install 6 million heat pumps in California by 2030. That's the kind of scale up that we're kind of talking about here. And so they brought the major manufacturers into the room and said, can you do this? And the manufacturer said, yeah, we can do that. We just need the demand. So the technology exists. The industry says, if you buy it, we'll make it. And it's a matter of getting these, like McGee was saying, utility programs are not going to fund this transition alone. It helps, not knocking utility incentives, but we need a lot bigger than that. And so I think it's about making that economic case, whether that's due to multiple value streams coming together and better valuing some of these non-financial benefits, as well as bringing down the upfront costs. There's a couple different pieces that are going to come together. I think McGee's solution is really exciting there. But can we do it? Yeah, the IRA is key. It's a down payment, as was said a year ago and has still been noted. But I think you look at some of the major technology revolutions we've had, the rise of the automobile, the space race. These things happened faster than people may have expected, and so the economy of scale is a really powerful thing. And when you hit that tipping point, it can really take off. So I do think it's possible. I think focusing on making the economics work to scale is key, because businesses are here to make money. So let's make sure they make money in this transition.
Thanks, Alexi. And so I'm wondering, Brett, if you can chime in on this, especially in relation to large buildings. You were talking about transition planning and the need to have transition plans, but even within the context of those transition plans, do you feel like the technologies are available, and not even just the technologies, but the solution sets that could be implemented as early as 2030 as part of a full transition? Do we still need to be installing any kind of natural gas equipment, fossil fuel equipment past 2030 or even now?
Yeah, that's so. We have the technology to do this. I think the challenge in larger, more complex buildings is going to be is breaking the cycle of like for like reactionary replacements, because if you're waiting till your steam boiler goes out and then suddenly you have an emergency situation, you just have to replace your steam boiler, that is never going to get us to decarbonization. I think the solution, and we need and there are leading practitioners and even portfolios that are demonstrating how to do that. The question is how to do it at scale. I think with larger portfolios, one of the forcing functions may be in increasing acknowledgement of risk and some prioritization of sustainability within portfolios, which is going to prompt some rational approaches. So those are sort of for the more well-resourced portfolios who can take that rational approach. But there's a whole other range of buildings that, the sort of one-off mom and pop owned building types, which are going to need to be served by a supply chain that's ready so that they have an easy button, a one-stop shop. That's the part where there's innovation needed. It's not the technology, the hardware, the widgets, it's the business models to deliver those in a turnkey fashion, so that we can achieve the 3 to 5 million building retrofits per year that are going to be needed to hit our 2050 targets. And so it's an opportunity. Somebody's going to figure it out and figure out how to make money doing this too.
So thank you. And so it feels like from a technology perspective, we're ready, but there still are a number of barriers. You mentioned some in terms of business models, mental models around like-for-like replacements, and just kind of the what we've habituated to over the past 20, 30, 40 years and previously. And then Alexi, you also mentioned some barriers in terms of supply chain, in terms of building demand, things like that. So we know that there are still these barriers. There are a lot of ways of dealing with those barriers, but can they actually be implemented in the time frame that we're looking at? And that's one of the issues that I really see, and some of you have pointed this out as well, is that we have these existing mechanisms for delivering efficiency. We have these existing ways of driving market development and market transformation, but are they really up to the task of completing this job in just over 25 years? And so McGee has been describing an alternative that could potentially address some of these barriers that you all are raising. How do you feel about the potential for that kind of solution or other solutions that look differently at how to value the transition and value decarbonization? How do you feel that this might be able to address those barriers? And then also, McGee, feel free to chime in as well with how you think it might address some of those barriers.
I think it. I don't think we have a choice. We can't continue to rely on the same old way that we've done things up until now. And it's sort of like, to borrow another misattributed quote, insanity is kind of doing the same thing over and over again and expecting a different result. And so, like, utility programs are great, but they're sort of part of that mindset of like, oh, well, it's the individual's responsibility to like decarbonize their own properties or, their own carbon footprint. I see the troll in the comments, like, oh, fear, uncertainty, and doubt being spread by the oil and gas industry. This is the reality of like most of the programs that we operate, is that there are these kind of conflicted, half-hearted attempts to maybe change a few individual actions, but not result in any sort of systematic overhaul of the way in which we're delivering electricity or energy. And so we have to think fresh about this right now, right? We have to get out of the mindset of like, well, okay, we'll increase our utility program budget by 10% or something like that. It's just like not going to make a difference. And we have to center climate in our discourse. Like, we can't just sort of sit here and kind of continue to like talk about, well, the energy value of this, the energy value of this. That's a fossil fuel construct, right? That ignores the fact that we have this existential threat facing us, and that buildings are core to both the reason that threat exists as well as to the solution of it. And so if we don't get out of that and in a hurry, then we're just going to be treading water for the next 6 years. It looks bleak at that point.
I talked a little bit about multiple value streams, and you can say, I'm doing this project, I'm putting a battery in to get resiliency, but I might as well do this decarbonization stuff. But that's two value streams in the same thing. Sure, important for project by project considerations, but we can take a step back too. As a society, we make enormous investments regularly. Look at infrastructure funding for roads and ports, stuff like that. That's done to preserve value, to make sure our economy can keep ticking along. That's also done to ensure future returns, right? Economic growth, jobs, it's an investment in the future. And so building scale decarbonization investments, okay, we know it matters. That's where the carbon is. We know how to do it. And they can preserve value. They can offer future returns, sure. But we're also just ignoring a whole category of value, which is the value of avoiding these vast disruptions to our economy driven by climate change. What's the value of avoiding millions upon millions of climate refugees by making it possible for those people to stay in their homes and not uproot their lives and go somewhere else where they incur these huge costs, right? As a society, we're not really very good at medium-term and long-term value decisions. By nature, we think of things in sort of really high short discount rates, if you want to put it that way. But the point is, we're talking about, should we push off these big investments now, regardless of whether they avoid enormously larger costs down the road, and whether that investment rate is 5% or 10%, when you're talking about a cost of climate inaction of something like $2 trillion a year, which are some numbers that have been creditably thrown around, scenarios that cut 3 to 10% of our GDP by the end of the century. That's from the White House OMB, the Office of Management and Budget from last year. It really starts to look like our current investments are just kind of nibbling around the edges. So I would argue that in terms of a value proposition, some of these things are a little hard to pin down very precisely, but they're so big that whether they're 10x or 1x, even the 1x is really, really big. So I think we should be considering a bit more holistic value proposition in a bit longer term than us humans are sometimes good at doing.
Thanks, Alexi. I think that's a great pivot to thinking about the strategic investments that are really necessary for this. We can see that they are massive. They're very, very large, and that our current mechanisms for financing and funding may not be up to the task. And it may be that there isn't enough available funding, or maybe it's too administratively burdensome to roll out. So I wanted to see what the panelists think about this need for much larger investment, and what is the role of things like CPACE or different ways of valuing decarbonization, these other kinds of mechanisms that people want to bring online. Are they enough? What kind of public investment do we really actually need at the level of transportation infrastructure? We have multi-billion-dollar transportation budget bills in all of the states. We have nothing like that for building infrastructure, but we can see that these costs are very high, and that the incentives alone aren't really enough to necessarily move the dial. So David, feel free to chime in on this, and anybody else who wants to think about this from this investment perspective.
Yeah, so look, on one level, there's plenty of financing. I got a wallet and it's got plenty of credit cards. And so there's financing. So that's an issue, but really the issue is quality financing that's affordable and that's directed towards the enormous problem that we have. So I want to distinguish between financing and directed and quality financing. On the latter front, doing that, no, there isn't enough. And we need to, I made a list of who needs to support this. Oh, look, it's everybody. It's the committee of the whole. So it's the federal government, state governments, it's utilities. And if it's utilities, if they're regulated utilities, therefore their PUCs or state regulators need to be part of it. And it's private lenders, it's individuals. So we need all of the above because of the magnitude of the problem. But I think it's clear now that there is not enough money or political will to do this by grants or by direct funding. That's a huge role, but it's not enough. And so we're going to need lending to be part of it. That's what my office does. And say we do it for virtual power plants, we do it for big things, but we need to have more utilities doing it, more state governments doing it through green banks, more other parties. One other thing I'll add is, people like us talk about market transformation, right? And how we transform markets for heating hot water. Another part of it is clean energy financing market transformation. How do we get private lenders to better understand that the risks are lower than they think, and they can charge lower interest rates? So we also need to transform finance markets at the same time. And many players are. I'm not taking away from their work. So there's a lot of things there. But yeah, we need to do all the above, and not just grants, but grants and financing for those who can afford take a long-term approach and pay it back.
Thank you. Well, we only have a few more minutes here left on the panel, so I wanted to close with kind of a more overarching question for all of you, but that hopefully maybe synthesizes and helps bring these things together. So the question is basically, can we get there? And not just get there in terms of the technologies, but can we really achieve this? Maybe it's not even just the scale, it's more of the pace. Can we achieve this pace? Can we get there in terms of pace? Why do you think that way? And what are some of the most immediate things, milestones that you think that we need to accomplish or hit in order to get there? And I suggest we just spend the last 5 minutes going through and see if we can have each of you spend about a minute or so, 60 plus seconds, on what your answer to this monumental question is. So I'm actually going to start with Brett, because we haven't heard from you, Brett, in a while, and I think it really connects into the work that you're doing with these large, trickier buildings in New York. So
yep. Yeah, in 1 minute closing minute, I would like to see the advent of decarb ESCO approaches, and a place to look for leadership actually is our federal government, federal portfolios, who are pioneering merging ESCO or ESPC sort of traditional funding with incentive dollars that are coming from the IRA, as well as capital budgets as well. If we can figure out how to marry those together, and then engage multi-system projects as opposed to just individual system projects that ESCOs have traditionally done, that's going to be a huge breakthrough. That's what I'm watching for.
Thank you. And Alexi?
I want to see it be dead easy to put heat pumps in buildings, where if my water heater burns out, there's a replacement, it's on the truck, I make a phone call to a contractor and it shows up. If that takes complicated tax credit stuff, incentives, layering, somebody else layer all of that. Don't make me bother with any of it. Give me a one-off, yeah, do the thing, and off we go. For the most part, the economics are ready for replace on burnout. As it stands now, if it should be packaged with efficiency, sure. I want to see these like turnkey solutions that are, maybe they're supported by complex formulas, but real dead easy at the building level for residential, commercial, and institutional or industrial users, so that we stop putting in air conditioners and furnaces. We stop replacing gas water heaters with gas water heaters, right? And it's not just the appliance level, but I'd like to see a real simplification, and that's a huge business opportunity. So I would love to see the people doing that be remunerated well for creating a new industry and taking it and running with it.
Excellent. David, your thoughts?
Yeah, well, look, you're asking two questions, Poppy. Can we and will we? The will we, sorry, we have to meet at the virtual bar at the end of the day to discuss will humanity deal with this problem. But let's talk about the can part. That's a little less discouraging. Can we? Of course we can. And so to me, I'm just going to focus on one aspect of buildings. Most of buildings emissions, depends where you live, but most of buildings emissions, well over 2/3 nationally, comes from the electricity they use, not from direct burning of fossil fuel on site. So to focus on that part, what buildings need to do is not only be more efficient, but be more demand flexible. So it's the responsibility of buildings, I would submit, to be flexible and smart and connected so that they can help integrate in the clean power grid that somebody else outside of buildings is building. So I just want to focus on that part and say that doesn't have to be as expensive. We need to have better windows and insulation and all that, but the demand flexibility doesn't have to be as expensive or as difficult, and will help integrate as the power grid becomes more based on decarbonized sources. So that's my answer to what we can do in the building sector.
Thank you. And McGee, your final thoughts?
Last word here as time is expiring. Listen, there's 250 people on this call today. I work every day with companies on the front lines, doing this work, the Block Powers, the Elephant Energies, the Quick Carbons, the solar haulers, Leap doing, demand flexibility. It's incredible to see the amount of innovation, the enthusiasm, the energy that's going into this work today. I have no doubt in my mind that we both can and will make the progress that we need over the next 10 years to hit the marks that we need to make sure that my kids, my grandkids have a great place to live as they grow up.
Well, thank you. On that positive note, I'm going to wrap things up. Thank you all so much for participating in this great discussion. And thank you, audience, for tuning in for this discussion. And I hope you all have a great rest of your conference today. I'm going to hand things back over to Carrie.
Thank you all so much. That was a really inspiring series of presentations and discussion, leaving me on a very hopeful note, McGee. So appreciate all of you lending your expertise to us here at the conference. So a big thank you from the Smart Building Center. So we're going to adjourn now to sponsor breakout rooms for the next 30 minutes. These should be visible in the WebEx events platform, but if you have any issues locating them, or if you have any problems throughout the day, please go to our conference website, sbxconference.org, and look at the agenda page there. We have contact information for people who can help you out. And don't forget, the sponsor breakouts are Zoom meetings, so you can turn on your camera and you can interact with the sponsors and with one another. So thanks so much. Round of applause, Zoom round of applause to all of you. Enjoy the rest of your day. And yeah, that's it.
Thank you all.
Thank you.